Here we go. All right. Let's talk about the calculations again. We're going to do, I'm hoping to get through 2 4-step problems today. And so we're going to talk about the entire process today. Let's talk about the calculations. All of our calculations that we are doing is under the assumption that the null hypothesis is true. Because remember, what we are trying to figure out is if the null hypothesis is true, which in the case of this example is saying if I'm actually an 80% free throw shooter, then what is the probability of getting the sample that I got? So we are going to use, when we do our checks and when we do all of that, we're going to use the null hypothesis being true in our calculations. In other words, that's why I said we are going to use, that's why I said we're going to use P naught. So in other words, the proportion of the null hypothesis, which in this case is 0.8. So the mean is 0.8, and the standard deviation minus 0.8 over n, or square root of PQ over n. Square root of 0.8 times 1 minus 0.8 over n. So that's going to be our standard deviation, mean and standard deviation. And this is the part that I want to slow down that I did really quickly yesterday. How am I going to do that calculation? Well, we're going to do it with a normal distribution. And we can use a normal distribution because n times p and n times 1 minus p are both at least 10. That was our normal condition. So we can use normal distribution here. So mean is 0.8. Standard deviation, I'll use 0.05 just for the purpose of this example and keeping the numbers good. 0.85, 0.9, and so on. Here's 0.75. Here's 0.7. And my percentage was 0.64. So it was down here. And we are finding what is the probability of getting this low of a sample. Because remember my 2 possibilities. My 2 possibilities are I had a bad run of free throws and I just happened to get a bad sample, or my free throw percentage is actually lower. And so we are calculating the probability of this part. And we are doing that with our normal distribution. So how do we do normal distribution calculations? We do it by calculating a z-score. So our z-score formula is value minus mean over standard deviation. Our value here is our statistic, the 0.64. The mean was 0.8. The standard deviation was that standard error of square root of p times 1 minus p over n. So that is the formula that we're going to be using. This is, by the way, just like with the confidence interval structure, on your formula sheet, the confidence interval structure has like the statistic plus or minus the critical value times the standard error of the statistic. Right? That was your structure of what the confidence interval formula is on the formula sheet. This is what the test statistic formula is on your formula sheet. And our test statistic here is a z-score, and then we're going to put in all of those pieces. So let me show that a bit better here. There it is. So this test statistic equals statistic minus parameter over standard deviation of statistic. That is what will be on your formula sheet. And just like with the confidence interval, you're going to fill in the pieces based on which formulas you're using. And that'll be depending on whether you're using proportions or means. So we're going to start by talking about proportions. That's what we're going to do this week. So there would be your z-score. And the probability with the z-score would be normal CDF. Normal CDF if we have a z-score. Lower, upper, mean, standard deviation. And that probability is the p-value. That probability is what the p-value is. It would be the probability of getting this bad a run of free throws if my free throw percentage were still that 80%, that 0.8. So, 4 steps. State, give your null and alternative hypothesis. Define your parameter. Define what P is. What is usually a proportion of some kind. Give your method. Right now we're going to be doing a 1 proportion Z test. Test, not interval, because now we're not doing confidence intervals anymore. So 1 proportion Z test. Then we're going to do our calculations. That's going to involve getting my test statistic, which in this case is going to be a z-score, and then getting out my p-value. Then we're going to interpret and get our conclusion. That's going to be our sentence of, because the p-value is bigger or smaller than my alpha level, we reject or fail to reject the null hypothesis, and that tells us whether or not we conclude the alternative. So again, those are your mean and standard deviation formulas. What you should not do is try to memorize this formula. Do not try to memorize this formula. What you should do is you should recognize it as a z-score formula and plug in the pieces. So z-score is value minus mean over standard deviation. That's your z-score formula. And so what's the value? It's whatever the proportion of my sample is. The mean is whatever the null hypothesis says. Standard deviation, this is my standard deviation formula. It would be on your formula sheet. So you take those and slot them into those places in the formula. And again, exactly how we're going to do that calculation is going to depend on whether we have a one-sided or two-sided test. So if this over here were a two-sided test, we would want both tails instead of just the one. Okay, let me... No. I'm going to bring it over here. Oh, just make sure you check your conditions first. Don't forget to do that. All right, here we go. give you a warning. Be ready to potentially have to snap some pictures because I'm going to be moving quickly. Or if you need to write something down and I go too quickly, you can go back and watch the video. And then you can pause it and write everything down you need to write down. I don't want to get bogged down by too many details. All right. I'm going to try and get through 2 of these 4-step problems here. Here we go. Producer has just received a truckload of potatoes. If the producer determines that more than 8% of the potatoes have blemishes, okay, we did this yesterday, and we figured out what the null hypothesis and alternative hypothesis was. And that was from the fact that this says we are testing if more than 8% of the potatoes have blemishes. That tells me my null and alternative. Remember, your null hypothesis should be your statement of equals. Or that there's no change. So our null is that P is 0.08. And our alternative is that P is greater than 0.08. So here's what we put in step 1. You're going to put your null and alternative. You're going to define the variable. What was P? P was the proportion of potatoes that have blemishes. The other thing you should put in step 1 is you should put your alpha level. And it says carry out a test at the alpha equals 0.1 significance level. So alpha is 0.1. Remember, the alpha is going to be our cutoff, our threshold, to say if the probability of the p-value that we get is above that, we're going to fail to reject. If it's below that, we're going to reject. That's our cutoff for whether we reject or fail to reject. That's our step 1. Step 2. This is called, it uses more words, but we're going to call it a 1 proportion z-test. We're calling it that so that we are matching what the calculator has. So when we go into calculator, we know where to go. So 1 proportion z-test. All right. Conditions, I'm going to go quick. Random. Does it say we have a random sample? Yes, it does. It says we have a random sample of 500 potatoes from the truck. Normal. Don't forget, all our calculations are going to be based on the null hypothesis being true. Assuming the null hypothesis is true, what's the probability of getting this sample? So we're going to use the null hypothesis when we do our n times p and n times 1 minus p. So we are checking n times p naught and n times 1 minus p naught. That's the part you need to write down. You need to write down n times p naught, n times 1 minus p naught. Write down what they equal. You should write down that they're both at least 10. Since they're both at least 10, then we have our normal condition. Independent, they probably produce a lot of potatoes. So the only real difference in the conditions are that your normal condition should be based on the null hypothesis. Right? I haven't written down p hat at all yet. We will in step 3. But the rest of your calculations should be based on our null hypothesis being true. So when we did n times p and n times 1 minus p, that was with p naught. Good so far? All right, I'm moving on in 10 seconds. Step 3. This is going to be the same idea that we did with step 3 last time, which is the things we need to have in our step 3 is formula, plug in your numbers, answers. Now we write down p hat. Again, I do not have the formula memorized. I know we're doing a z-score. And I know that I want to use the value. What's the value? The value is the value from my sample. Minus the mean. Well, we're assuming the null hypothesis is true. So the mean is just the proportion of the null hypothesis. If p were actually 0.08, then the mean should be 0.08. And then what should the standard deviation be? That should go on the bottom. What's the standard deviation? The standard deviation is square root of p naught times 1 minus p naught over n. So that's your formula. P hat is 0.094. And then our P naught was 0.08. The null hypothesis was that it was 0.08. N was 500. And then we're going to be able to jump straight to our answer. And then give the p-value. So I'll show that in just a second. You're going to see more written down up here than you will need to write down. Formula, plug in the numbers, answer. So we want the probability that z is greater than 1.15. Since we want, since our alternative is that p is greater than 0.08, then my probability that I want is that I get that large an amount having blemishes. So that's the probability that I'm going to find, and the p-value there is going to be 0.1251. So this is what the distribution looks like and the probability that we're trying to find. And we're going to do that in the calculator. I'll show you how to do that in just a second. How to get out this value. But before I do that, I want to do our step 4. So again, equals 0.1251. This is what you need to write down in step 3. Formula, plug in the numbers, answer for the z-score, answer for the p-value. That's what you need to write down in step 3. Step 4. We're going to write our same sentence that we've been writing down in any conclusion. So what was our alpha level again? It was 0.1. So this p-value is, fill in my blanks here, p-value is greater than my alpha level. That means we are going to fail to reject, which means that there is not enough evidence to conclude my alternative. What was my alternative again? Right. More than 0.08 of the potatoes have blemishes. Since our p-value is greater than the alpha level, fail to reject, not enough evidence that the shipment contains more than 8% of the blemished potatoes. So again, compare the p-value to the alpha level, reject or fail to reject. Is or is not enough evidence to conclude the alternative. So that is our concluding sentence. Make sure the conclusion of the alternative is in the context of the problem. Not enough evidence to conclude the alternative. What was the alternative? That the shipment contains more than 8% blemished potatoes. Ten seconds till calculator time.
Why did we use 100?
100?
Yeah, in the normal CDF.
Oh, that just gives, the normal CDF is saying, like, here, our lower bound is 1.15. Oh. Our upper bound is a really big number.
It's a really big number.
Yeah. We're actually not going to use normal CDF when we do it because we can actually skip that step. The calculator is going to do it for us.
Oh.
Calculator time. Well, that was anticlimactic.
Yay!
It came up. It came up over here. Calculator time.
Yay!
All right. Okay. I was going to say that's all the energy that she had. And then she just like leaned over against the wall. That's it. That's all I got. That's all I got today. All right. Stat, over to tests. It's our same menu that we were doing last time. Here's what it's going to ask you. It's going to ask you about the null hypothesis and the alternative. It's going to ask you what p hat was in the same way that you did with the confidence intervals. And then it's going to do the calculation for you. Here we go. One proportion z-test. That's what we're doing. One proportion because our null and alternative are about one proportion. And we're doing a z-test instead of an interval now. So one proportion z-test. Here it is. P naught. P of our null hypothesis, that's 0.08. X and N, so what's our, that's for P, that's to get P hat. So how many of the potatoes in the sample had blemishes? 47? Out of 500. Our alternative was that P was greater than 0.08. So we're going to go down here and we're going to select greater than for our alternative. If you hit draw, it'll draw a nice little normal curve for you with the probability there. But we're going to calculate. There's your p hat. Here's your z-score, the 1.15. Here's the p-value of the 0.1242. P hat was the 47 out of the 500. So then p is your p-value, is your final probability calculation that you get in step 3. So again, what you need to show in step 3, formula. Plug in the numbers, then give the z-score, then give the p-value. In the calculator, that's what you plug in. All right. Anyone need help with the calculator?
No, but so we now have to know the difference between P, P hat, and P naught.
Yes.
Great.
And p-value.
What's P naught again?
P naught is whatever your null hypothesis says.
And what's P? The proportion.
P is a general like proportion of the population.
What's P hat?
P hat is of the sample.
Okay. And then
So in this case, when we use P, we are defining it to be the proportion of all the potatoes that have blemishes. That's P. P naught is a specific number for the null hypothesis. So in this case, it was 0.08, because the null hypothesis says that P was 0.08. P hat is what you get from your sample, which in this case was the 47 out of 500 that we got from our sample. The p-value is the probability that we get out of step 3. So that is this final calculation that we're going to use to reject or fail to reject the null hypothesis.
what if the alpha level isn't given to us? Then you told us it's
0.05 is your typical alpha level. If it does not say an alpha level, we usually use 0.05. Just like the standard confidence interval is usually a 95% confidence interval. That's what you're going to do this is what you're going to do on your quiz on Thursday. I'm going to give you a 1 proportion z test, and you're going to do 4 steps. Let's get through as much of the next one as we can. All right. First off, I want you to read this problem and decide if it's a one-sided or a two-sided test. Ignore the header. I could be tricking you. That would be a great bamboozle. Had it with two-sided tests and then it's not a two-sided test. Man, that would be so mean for me to do. I think he's saying it in a sarcastic tone because he did do that. You did do that, didn't you?
Why don't we read them?
Yeah, he did do that. That's a good idea. Let's read the problem and figure it out. So if you're so confident, prove it by reading the problem.
I did, Mr. Huffman.
Do you have a question?
No.
Or you have your idea? Okay. Once you have that answer, give your null an alternative and define your variable. Again, we're going to use 0.05 here. All right, the key part of this question is we are looking at whether the result holds true. I was hoping this would be blue, and it's not. And now I'm sad. That's just what the PowerPoint gives. It's just what the, no. PowerPoint just wants red. I would have to go in and change the color of the pen within PowerPoint to do it. But that's okay. Point being, whether the result holds true. Do we wonder whether the result holds true in any specific higher or lower direction? No. We are just wondering, is this 50% figure true or not? So that is a two-sided test. I did not bamboozle.
He's lying. It's a one-sided test. He's still trying to trick us.
P is 0.5. The alternative is that P is not 0.5. We define our proportion, and we have our alpha level.
Okay, this has happened twice now, and I just want to make sure I'm not reading this wrong. It says we want to perform at test at the, is it a test or should we have that?
A test.
Okay, because it's,
Honestly, you don't need this sentence, and you can just write alpha equals 0.05. So you can write this. You should write this sentence where you define your variable, and you should write alpha is 0.05. It's still a one proportion z test. Check your conditions. Give your null and alternative, define your variable, give your alpha level. That's what you need in the first step. So go ahead and check your conditions.